Yes, we're going to need to factor. And yes, 80s, 90s. Not 90s. Huh? I have no idea what you're talking about. The grown-ups are definitely not doing a thing for Teacher Appreciation Week all by ourselves. Definitely not a aggressive theme week. All right, so yeah, we're gonna need to factor these things. So we need to look at the numerator at the top piece and see if we can factor it, and we're gonna look at our denominator and see if we can factor it. So.
For the top one, we do the x or greatest common factor first.
That is a great question. Should we do the x or the greatest common factor first?
That's not helpful.
I know. The very first step whenever we factor should always be to check for a GCF. So we do that one first. So is there a GCF on the purple part?
Yeah.
Of 2. Because I need to take that 2 out. Then we're going to get
Good morning, Pike High School.
x squared.
This morning we will have AP Human Geography. All students need to be released from class and report to room D129. This afternoon we will have
Faster.
AP U.S. Government and Politics. Students will need
Faster.
to eat a lunch and report to the fitness center at 11:30 a.m. Thank you.
Talk so slowly. All right, so that now, this guy we don't need the whole box where we can just do it with the x since that doesn't have an a value anymore. So we need a pair of numbers that multiplies to make 6 and adds to make 5. What pair of numbers multiplies to make 6 and adds to make 5?
3. 2 and 3.
2 and 3. So we can factor the numerator that 2 is going to hang out in front. Then we have our x with our positive 2. And x. We pulled out a greatest common factor of 2. So if I divide 2x squared by 2, we get our x squared. 10x divided by 2 gives me 5x. 12 divided by 2 gives me the 6. So if I was to redistribute this 2 through, I'd get exactly this. Oh, I'm just going to stare at the window. Yeah, otherwise you're going to get wrong factors. Don't act like you mean it, dude. I just saw you staring in the window. Like a lost little puppy. Just like a puppy pressed to the window. Hi. Not that you're making that face. Just that was what was in my head. All right, so let me do the same thing with our denominator. Factor that thing. See what I can do. So let's take a look at our x squared plus 3x plus 2. Our a times c, 1 times 2 gives us 2. Our b is 3. So we need a pair of numbers that multiplies to make 2 and adds to make 3. What numbers multiply to make 2? 1 and 2. Those are literally the only things that can multiply to make 2 that are integers, which is what we use here. And those do, in fact, add up to make 3, so those are our guys. So our factors here are our x plus 1 and our x plus 2. Yes. So what can we do to simplify here? There's 2x plus 2's. They can cancel out. So our simplified version, we've got our 2 and the x plus 3 left in our numerator. And we have just our x plus 1 in the denominator. There's nothing else we can simplify. So that's our guy. That's our answer.
So
we don't need to distribute the 2 if we have like only factors at the top. If I had like an additional plus 2 on the end, then we would want to distribute that so we can combine our like terms. Thank you. but we don't have to distribute that right here. Can if you want to. If you want to put it as 2x plus 6, totally valid. All right. We are going to do what feels like a very drastic shift today. It is kind of a chaotically random segment that has to fit in somewhere. And by putting it right here, it kind of sets us up nicely for a little bit of solving stuff. So if you look in page 20 in your notes packet, today's gonna feel really, really random. Because we're working with something called variation. And it is in fact not page 19, it is in fact page 20. But again, I put a cover on the notes packet after I did all the page numbers, and I didn't go back through and re-update them. So, let's fix it now. What's up? Page 20. I originally wrote the slides after I wrote the note packet, but then I went and put a cover page on it, and so all the page numbers got adjusted by one, and I never went back and updated them.
I don't see that last point on our thing.
Correct. The bottom line is not on there. It's kind of a me talking point. It is related to what we're doing. It's just going to feel very odd, and it is kind of in a precursory way setting us up for the solving that we need to do to finish out this chapter out. So it's one of these things that kind of fits here. Feels kind of weird, but it's getting us ready. I promise. It's doing a thing. It's doing a thing. So we're going to work with something called variation. And what that is it's relating two variables and it's telling us how they interact across an equal sign. So direct variation means they are directly across from each other. So it's going to say something like y varies directly with x, or a varies directly with b, something like that. And what that means is it's going to be y equals some number times x. That some number is one of the pieces we're going to try and figure out. Sometimes we're going to have one or more quantities. So if it varies directly with a term, it's y equals, or whatever it is, across the equal sign from that. If it's jointly, then both pieces are across the equal sign. So we're going to look at a couple of examples of these next. I feel talking through them makes way less sense. What we want and important pieces, which they are printed in the notes packet, are direct variation, looks like this. The y equals kx. Joint variation, if we got more than one things joined together, it's going to look like this. Y equals kxc. So we have lots of letters in here.
The only difference I see is the z.
You are correct.
I'm so confused.
That's okay. We'll look at it here in a second.
I don't like it.
That's okay. You don't have to. So this is, the bottom line is just kind of pointing out this does fit in this chapter. It is technically using our rational functions to solve things. What we're going to do is we're going to start just plugging pieces in. So, again, wrong page number. Let's look at number 1. So if we've got y varies directly as x, that is how things will be kind of worded. And I know that feels super awkward to say. Y varies directly as x means our equation is going to look like y equals some number times x. Y equals kx is how we word that. And what they do is they give us an example. They say, all right, for this particular situation, if y is -3, then x is 24. So I could take, I'm going to switch that to be two different colors here. My y to be -3, and it should equal that some number k times 24. So we could find k. How could I figure out what k is? If I have -3 equals k times 24. How could I get that k by itself? Divide by 24, because they're being multiplied right now. If we take -3 and divide it by 24, what do we get? What is negative 3 divided by 24?
Why? Yeah. Okay, that's gonna have to work. My limit. Negative 3. No, I didn't want the negative 3. Negative 3 divided by 24 equals negative 1/8.
Mm-hmm. So that means I know for this particular situation, I could rewrite this equation as y is going to always equal negative 1/8 times x. So each of these problems, we're going to have a different k value. K is called our constant of variation, but mostly it's just the obnoxious thing we have to find on each of these. So then what we're really asked to do, and the question we are trying to find the answer to, is find y when x is negative 16. So we know it's living in this world. I want to know what y is. So we're going to find y when we know our k is our negative 1/8. And if we substitute in our x to be negative 16. Using this equation, I'm just going to grab a arrow to put it there to find that. So let's finish that out. What is our y going to equal? What is negative 1/8 times negative 16? Mm-hmm. So the answer for this one is 2. Questions on this first one? Yes, dear. Say it again.
You're multiplying the negative 16 times the negative 1.
Correct. Because whenever we have something that varies directly, it's that we have an equation of this kind of form. It's always going to be y times a number times x. And we had to find our k for this situation. So it's our k times x. So it's that negative 1/8 times whatever our x is. And they told us to find y when x was negative 15. So they always in these kinds of problems will give us an example so that we can find our k. And then they'll give us one to find, like our quest. So this is the guy we really want the answer to, but we need this to figure out our k. So let's try another one. Let's look at our jointly. Same kind of vibe. If y varies jointly as x and y, that means my y is going to equal some number, k, times both x and z. They're all multiplying together. So this time they've changed our order. They've given us our problem. This is our quest that we have to find our answer to at the beginning. So I can't use these guys to figure out my k, because that's my find y. I need my answer. So our initial information that we can use to find k is we know that y is going to be negative 15 when x is negative 6 and z is negative 1. So we need to find our k. So we know if y is negative, ooh, that's not a pen. There we go. If y is negative 15, substituting the pieces in, it's going to equal some number, k, times our x, which is negative 6, times that z, which is negative 1. So you can write them like this with multiplication in between. If you want to put them in parentheses, that's totally cool. Bless you. So what we have right here is we have our negative 15 equals k times negative 6 times negative 1 is a positive 6. So how do we get our k by itself? Yeah, we need to divide. we're going to divide both sides by 6. So that we can get that k by itself, which means our k is actually, does that simplify? Negative 15 over 6. Say it again. Yeah, you can do it as a decimal or you can do it as a fraction. As a fraction, they're both divisible by 3, so we'd get negative 5 halves. If you want to do it as a decimal, that is absolutely valid, so it'd be negative 2.5. Totally valid. You can absolutely do these with decimals. I don't know. So that tells me our equation, I know my k now. So y is going to equal whatever our k is, that negative 2.5 times both our x and our z. So then we have to do the one where they've asked us a question up here. We're supposed to find y if x is 4 and z is negative 3. So we're going to take the equation we found, this guy, and bring it up over here. And we're going to substitute that in. We're trying to figure out what y is if we know our k is our negative 2.5. And we're going to multiply it by our x, which is 4. And our z, which is negative 3. So we need our negative 2.5 times 4 times negative 3. What is negative 2.5 times 4 times negative 3? So did I. We should get 30. Questions on these two? That's fine. So these ones you've actually probably seen before. It just might not have been since Algebra 1. These were like touched on very briefly in Algebra 1. The one that's really mostly like what we're doing in this chapter is actually the next one. Our inverse variation. So our inverse variation means that the two variables times together equals some number. So the way we can write our inverse variations look like this. We can either have it as y times x equals k, so the product of the two equals a number, or, and this is why it's over here in rationals, is because if I then tried to make that be a y equals, our x is in the denominator. That's why we're in the rationals chapter. Because now I have an x in the denominator, and that's icky. But it's the exact same kind of vibe. So they're going to give us some information. It's not always going to be x's and y's. Sometimes it's m's and n's and other letters. But it's structured the same kind of way. We've got m is varying inversely as n. It means we're going to set it up like one of these. So you can either write it as m times n, or you can write it as m equals k over n. Either way is fine. I'm going to do it as a product on this one. So our m times n equals some number k. K is called the constant of variation. Not a word you need to know, but it just gives it a name. And then again, it's going to give us an example. Like it sets us up with that m equals negative 4 when n equals 6. So if we know when m is negative 4 and n is 6, we can find k. What's k going to be? What is negative 4 times 6? But watch out for our signs, because I heard the 24 part, but we got to make sure we keep track of that sign, the negative. So it's actually going to be a negative 24. So then the one we're asked to find is we're supposed to figure out what m is. That's the same color. There we go. We're supposed to figure out what m is when n is negative 10. So using our equation, we know it's going to be that m times n equals that negative 24. So we know m times negative 10 is going to equal that negative 24. So what's m going to be?
I have questions.
I have answer.
Do we only have 3 types of variations?
There are 3 types of variations.
Okay.
Yeah, we're going to divide both sides by that negative 10 in order to get that m by itself. So we're having to divide by some of the pieces. Dividing by the thing we substituted in, thus makes rational. So what do we get for m? Yeah. I was going to say, it shouldn't be a negative, though, because we're going to divide negative 24 by negative 10. So we should get a positive 2.4. Okay. Questions on that one? Those are our 3 types of variation. We're going to practice all of them one more time. And just so we can see what those look like again. So if we've got y varies directly as x, then we're going to have 5, which is y varies jointly as x and z, and y varies inversely as x. So we're going to try each of these one more time. So for number 4, if we've got y varies directly as x, that means that's going to be y equals x times something. X times a constant. So directly, they're directly across from each other. So let's see if we can find our answer here. See what we can find for k. We're given this one, that y equals 360 when x is 180. And we're supposed to try and find y if x is 270. So we need to find our k piece first.
Aren't those all degrees?
Yes. Technically, you can use any number as degrees, but those are notable degrees, as in fact, one's a full circle, one's a half circle, and one's 3/4. But not particularly relevant to what we do in here. So let's substitute in the pieces we have. Thank you. Let's substitute in the pieces we have. We know that y equals 360 if x is 180, and it's going to times by some number. So we got to figure out what k is. What's our k going to be?
Wouldn't it be 2?
It will be 2. Because we divide both sides by 180. 360 divided by 180 gives us 2.
Yeah, I did mental math.
So that means we know that our equation is actually going to be y equals x times 2. Or 2x. It doesn't matter how you write it. So we're asked to find and figure out our y when x is 270. So we know it's going to be 270 for our x times 2. So So what's our y going to be? 540.
Struggle of using multiple colors.
It is. So we wind up with our answer being y is 540.
Putting it in parentheses, if I put 2 in parentheses, that means the same thing.
It does the same thing. Yep. Yeah, you can either write it with the dot or you can write it like that. 100% the same thing. Because that's the one we were asked for here. Because we put it in as the x. Because they said our goal, our job here, our goal, the problem we were asked to do is find y when x is 270. So we needed to find the k, so we knew what to do with the x. That's how we find our y. It's almost like a system of equations kind of thing, because we have 2 pieces that we need to do. That was what the blue piece here is for, is they give us an example. And so we take this one, so the directly, I'm just going to do a highlight real quick. So when it says we vary directly, that means we use this structure. Mm-hmm. Yep. So we use the word to figure out the basic equation, the example to figure out the k, and then we can plug in and chug our stuff. So if y is varying jointly as x and z, or varying jointly with x and z,
That would be.
that means our y is across from my x and z and some number k. So it doesn't have to just be x times z, can it be x times z times something. You'll be okay.
Good thing the other colors.
So they've given us our example here of y equals 16 y equals negative 16 when x is 4 and z is 2. So they're giving us our example piece here. We know that y is negative 16 and x is going to be 4. I'm going to do this one in parentheses just since we have so many pieces. Our z is 2. And it's still times that sum number. We don't know what that number is yet. That's what we're using the example to find. So we can simplify this a little bit. We can get our negative 16 equals 4 times 2. We can do that. 8 times some number k. So what is our k going to be? What is the next step for us?
We should divide, so then k equals -2.
Yeah, divide both sides by 8. And negative 16 divided by 8, we get a negative 2. That equals our k. So that means we know our equation is really going to look like y equals x times z times -2. So then the question we were asked, our problem for this one is to find y when x is -1 and z is 7. So we can substitute those pieces in. It's a plug and chug kind of situation. So our y we are going to find by taking our x of -1, our z of 7, and that's going to then still be times that -2. That looks like a z, but that's why I crossed my z's, because that's actually a 2. And then it's just a multiplication, because all my things are on the same side over there. So we have -1 times 7 times -2. 14. Because that -1 times the -2 makes it a positive 2. 2 times 7, 14. So this guy's our answer right here. Questions on this one? So we got one more. So then we've got our inversely. So directly they're on the same line. Jointly they're on that same line with the opposite sides of the equal sign. Inversely means my letters are all together with my k on the other side. It's my x times y equals k. Or you could set it up. That is not the pen I wanted. There we go. You could set it up as y that is not a y. That's an x. There we go. Y equals k over x. It does not matter which way you go. They're going to get you the exact same answer. It does not matter which form you use. I tend to like this one over here better, the yx equals k. It feels less gross than having the k in the denominator, but you can do whatever works for you. It just requires slightly more steps when we're mathing. So the example that they give us, our first step is to look at our y equals 6 when x equals 5. So we know that our 6 times that 5 is going to equal k, that constant. So what is our k going to equal on this one? 30. So then the problem we're given, the one we're asked about, what is he looking? So we're asked to find y if x is 10. So we know our k is going to be 30. So we know our x times y is going to equal 30. So we know that our 10 times y is going to equal 30. So what is y going to equal? If 10 times y equals 30, what's y going to equal?
3.
3. Divide both sides by 10. So there's a lot of dividing when it comes to kind of solving these things. So we substitute our pieces in, and that lets us do that division.
Is this the last one for today?
Tomorrow we're going to look at those kind of story problems on the next page and how they relate and why the heck we care and what is going on here. And then we'll get into solving of our more like analytical ones, and then we'll wrap it up with some more story problems.
Yeah.
So that's kind of the vibe. So we'll do some story problems tomorrow, then we'll do some solving, then we'll do some more story problems, and then we'll be done. That's the plan, because we only have like 5 pages left. So that means
Yeah.
we only have 2 more homework assignments, which means I might give you one now.
It's okay.
So this is the second to last of the homework assignments. Yay! And you guys can do everything on the front and half the back on this one. Because the front is exactly what we were just doing using our variations. And on the back there's a section where it's just saying is it direct or joint or inverse based off of how the equation looks. So it's using all those same pieces. So the only thing we really haven't done is the very top one on the back, which is the story problem. You might be able to figure it out. But if not, we're going to talk about it tomorrow. So here is the variation homework. We are going to do that kind of story problem like number 25 on the top, on the back tomorrow. So yeah, that's kind of the vibe.